Alright, so today we're going to be talking about pan-balance equations. Last time we talked about pan-balance problems where we used a pan-balance to model some problem-solving strategies. Today we're going to replace using oranges and marbles and paper clips and pencils with using numbers and variables. So we're going to follow the same two rules that we did last time, is that our pans must always stay balanced. And the second rule is that we need to make equal moves. By making equal moves, we keep the pans balanced. So once again, we are using the same strategies, just replacing the objects like oranges with numbers or variables. So we're going to begin with the equation 3y plus 10 equals 7y minus 6. You'll notice I'm using the pan. I have the equal sign because both sides are equal, and my strategies are going to remain the same. I'm going to try to get all of one thing to one side of the pan and all of the other thing to the other side. In this case, I have numbers with variables, and then I have numbers without variables. So I'm going to try to get my variables all to one side and my numbers all to the other side. So the first thing I'm going to do is look at this problem and say, okay, what can I do to get one thing all the way to the other side? And I look at this 3y, and I look and say I probably can subtract that 3y. So I'm going to write that out to the side here. Subtract 3y. And I'm going to subtract 3y from each pan. If I have 3y and subtract 3y, I'm left with 0y. So all that I have left in this pan is 10. On the other side I had 7y. If I take away 3y from 7y, that will leave me with 4y. And then I have my minus 6. So I've got rid of my variable on the left side of the equation, so let's try to get rid of my whole number on the right side of the equation. I notice that I have a minus 6 over here. How do I get rid of a minus 6? One thing I could do is to cancel that out is to simply add 6 to both sides. If I add 6 to the left side of the pan, I have 10 plus 6, which gives me 16. I've added 6 to that 10. If I have 4y minus 6 plus 6, the minus 6 and plus 6 will cancel out, so I'm just left with 4y. So now I have 16 equals 4y. The final step of the equation is to try to get rid of that coefficient, because I want to try to find what 1y equals. So the coefficient is the number out in front of the variable. To get rid of that, what I can do is divide. In this case, I'm going to divide by 4. I have to do it to both sides, so 16 divided by 4 leaves me with 4, and 4y divided by 4 leaves me with y. So my solution to this problem is y equals 4. I want to go ahead and check my answer by plugging that back into my equation. So my equation said 3y, which now is 4, plus 10 equals 7y, which we said is 4, minus 6. If I do the math behind that, on one side I get 3 times 4, which is 12, plus 10, which is 22. On the other side of the equation I get 7 times 4, which is 28, minus 6, which is 22. So I have found the correct answer. Y equals 4. So you see how you can use pan-balance strategies to solve equations. One other thing that you can use pan-balance equations for is to actually create equations. Let's take a look at how to do that. If I start with a pan, I can start with my variable. Let's just make my variable x. And I can pick any number that I want my variable to equal. So let's just pick 4. Now, what I can do is kind of use the same steps to actually create an equation where x would be equal to 4. So I just do this by going step by step, keeping the pan balanced and making equal moves. So let's say the first move I want to make is let's multiply by 3. So we're going to do that to both sides. If I take x times 3, I'm going to be left with 3x. If I take 4 times 3, I'm going to have 12. So my equation's starting to change already. I have 3x equals 12 now. Now, let's change it a little bit more. Let's go ahead and add 5x to both sides. If I add 5x to 3x, 5x plus 3x would give me 8x. And if I add 5x to 12, well, I can't add those, so I would have to simply write it as 5x plus 12, keeping the variable separate from my constant number 12. Let's just do one more thing. Let's go ahead and subtract 4. So if I subtracted 4 from both sides, I would have 8x minus 4, because I can't take away the 4 without knowing what the variable is. And then 5x plus 12 minus 4 would leave me with minus 8. Or plus 8, I'm sorry. So I have 8x minus 4 is equal to 5x plus 8 as my equation. I have created an equation where x should equal 4. Let's check that really quick by working it out. If I have 8 times 4 minus 4, that should equal the same thing as 5 times 4 plus 8. Let's see, 8 times 4 is 32. 32 minus 4 is 28. On the other side, I have 5 times 4, which is 20, plus 8 equals 28. So I've created an equation using the pan balance model. I started with x equals 4 up here. I did my steps over here and ended up with an equation where x did equal 4. So I used the pan balance strategy to actually create equations. So through these examples, you can see how you can use our pan balance strategies to do two different things. First, you can use them to solve equations. By making equal moves, you can get down to the variable and a whole number. The second thing you could do is use it to create equations, where you start with a variable equal to a whole number, and then to begin to make changes to get more complex equations. Good luck in your work in using these pan balance strategies to solve equations and create equations.